Okay, Math Cats, I'd like to say a few things here about what I'm going to call the language of algebra. Let's see how language. You thought you were in math class and you didn't need to learn any vocabulary, but I'm afraid you do. Now, remember I said the Indian people had separate symbols for letters, A, B, C, D. They weren't A, B, C, D, whatever they had, and then the Arabic numerals 1, 2, 3, 4, 5, etc. It goes on forever and ever. And when they made this distinction, letters that could be used to make words and then symbols that stood just for numbers, it made possible this thing called algebra, because any one of these letters could stand for a mystery or an unknown number. So if we had our letter A, he's sitting here and we don't know what he is, but we can still do math on him. So let's see, A may be a mystery number, but we could say we have A plus another A. Well, this A by itself must stand for one of those A's, whatever we have, and this must be one of those A's. So 1A plus 1A is 2A. Well, I don't know how long it took, but pretty soon somebody decided that this number that was in front had to have a name, so we didn't have to say the number in front. Right here, the number in front of this A is understood to be a 1, and this is a 1, and 1 plus 1 is 2, and when you add A's to A's, you get A's. You don't change the A's. So they called this number in front a coefficient. Now, I can remember when I was trying to learn this, I thought, oh, I remember that. And the meaning like co-chairman or efficient, together, efficient, is what I latched onto, the this number in front. So any number that's out in front of some algebraic letters is its coefficient, like 5a squared b. The 5 is the coefficient. The other things are variables that we don't know what they could be. They could be anything. We don't know what they are. So when we add, we did that. And when we subtract 5a minus 2a, we get 3a, and the coefficient here is 5, the coefficient here is 2, and the coefficient here is 3. Then they came to multiplying. They said, how will we represent multiplying? And so if we said, I want to multiply 5a times 2a. Wonder what happens then. The coefficients here, if it had just been 5a, if it had just been 5 times 2, the answer would have been 10. So let's make up a mystery number value. Just say a could be 3, and it was just that. Let's see what would happen if we did this. If this were the real answer, which we don't know for sure, this term would really stand for 15, and this would stand for 6, which would mean that we have 6 times 5 is 30. This would be worth a 90. We want to make sure that whenever we do arithmetic on this, when we don't know, if we knew that the a was worth a 3, we would at least get the right answers. So let's see. 5 times 2, that's 10. And a times a, a times a. Would that be the right thing? 3 times 3 is 9. Times 10 is the 90. Sure enough. So they said that this is the way we would do this. Multiply the coefficients and then put the letters next to each other. Well, that presented its own set of problems. What if you had a times a times a times a times a times a? Well, the mathematician said, that's kind of silly. And, you know, mathematicians, I've noticed over the years, they don't like doing a lot of writing. They always want to have shortcuts for things. So they thought, 3, 4, 5, 6. If I had to write that A down 6 times, why don't I just make up another notation? So they said, let's let this be A and put a little 6 in the air, and we'll call that an exponent. It's like an extra number. There are really extra numbers of these A's. There are 6 of them altogether. So we have this exponent. So let's take just a regular term. Oh, I called it a term. 5a to the 5th. Oh, that was not so good. Let's make this a 6 because we don't really want them to be the same. 5a to the 6th. This 5 would be the what? Coefficient. This 6 would be the exponent. And this a is a base for the variable. The whole thing, since everything here is multiplied together, is called a term. So we have this vocabulary: coefficient, base, exponent, term. Since this is on video and you can play this as many times as you want, I'm going to go on and talk about terms a little bit. So if I have 5a squared b, that's a term. Everything there is multiplied together. And if I tried to add that to 6a cubed b squared, these terms are not like. The a squared b is not the same as the a cubed b squared, so we can't combine them. The answer, if you said to add these, would have to be the problem itself because it's combined as much as possible. We have one multiplication unit. This is a term. This is another multiplication unit, and it's a term, so we say that this whole expression has 2 terms. Now, I know that a lot of you have at home a bicycle. I'm not a very good drawer of a bicycle. Let's put a seat on it and put handlebars on it. There's a bicycle. We call it a bicycle because it has 2 wheels. This thing right here that has 2 terms is called a binomial. And imagine this is some sort of hangover from Latin. Nomial is numbered. This is binomial. If I said a squared b, 3 of those, plus 6a cubed b squared plus 6a, there would be 3 terms, and guess what that's called? Not a bi, but a little boy next door to me has a tricycle. This is a trinomial. Anything that has lots of terms or more than one term, one with only one term is called a monomial. Like a monorail, that's a train that runs on one track. Monomial, binomial, trinomial. Anything that has more than one is called a polynomial. And sometimes you'll see in books these sections called polynomials, and that's sort of like a bigger category. Anything could actually be called a polynomial because it says it has many numbers. So there's some vocabulary for you. Try to pick it up, try to use it. I will try to use it, and then we'll know what we're talking about. Thanks. Bye. Well, Math Cats, we did the coefficient and the base and the exponent, that vocabulary. Now I want to talk to you about the degree of a term. When I was learning about the degree of a term, I think I was studying something in biology. I had just learned about burn victims, and it was kind of gross, and I've always used it as an illustration when I've been teaching. Somebody was accident and there was a fire and they say they got third-degree burns or first-degree burns. What does that mean? It's kind of a measure of how badly burned people are. And I hate to talk about it, that makes me go, yuck. But if you say you have first-degree burns, that just goes on the top layer or something, then it gets worse and worse. Well, when Mr. Cosgrove started talking about the degrees of a term, I thought, he's just telling me how bad is the term. So I'm going to start off with some simple things like 3a. Now you look at that and you ask, what's the exponent on that 3a? The 3 is the coefficient. We don't need to look at that when we want to find how bad is this term. This is a to the 1. This would be a first degree term. Now if I said 3ab, this is a to the 1 power, b to the 1 power. This is, how bad is it? How bad are the exponents? This would be a second degree term. Let's see how good you are at guessing. What if I said 3ab squared? This is an understood 1. How bad is it? Well, 1 plus 2. This is a third degree term. What about 5x squared y cubed z to the 4th? How bad is this? You don't do anything with the coefficient. He's just the coefficient. He's just the number out in front. You want to see how bad is this term. You add up what? The exponents. So we're going to say 2 plus 3 plus 4. 2, 3 is 5, and 4. This is a 9th degree term. Now, the problem that some students have is what we had in this example right here. When there's just a letter by itself, like if we had 4, A, B, C, what degree is that? 1, 1, 1. I hope you were right. It was a third degree term. Now we've just looked at individual terms to find the degree of a term. Now I'm going to delete all this and talk about the degree of the whole polynomial, because we've got something else going on here. Let's bring this up and start talking about the degree of a polynomial. So let's write down 5a squared b plus 3x cubed y to the 5th plus 2a. Well, do we add up all of the exponents in the whole expression? The answer is no, we don't. What you have to do is you have to examine each term. You better wake up. We examine each term separately. I hope I spelled that right. Don't pay attention to my spelling. So let's look at each term. Let's look at this first one, just like he was all by himself. What's the degree of this term? I hope you figured it out from before. This is a third degree term because the exponent 2 and the understood 1. This is a third degree term. This one is an 8th degree term. And this poor term right here is, with an understood 1 here, is a first-degree term? Now, remember I said when I was doing this, I was always thinking about degrees of a burn. And this is really the way I remembered this, or tried to make an example in my head to help me remember. I imagine there's this poor little kid, and he's gotten in a fire. He looks like a snowman. And he's got burned in 3 places. Right here is just a little slight burn, first-degree burn. And then he got a little bit worse right over here. And then and that was the second-degree burn. Then he got burned really bad over here. And they actually had to do a skin graft, and it's a third-degree burn. Now, when he went to school the next day, or next week or something, he was going to tell his friends about his ordeal. Do you think he's going to say, I had a first-degree burn? When he goes to, he shouldn't be smiling, should he? He was a snowman. Oh, well, whatever. Is he going to be telling his friends, boy, you wouldn't believe what happened to me? He's going to say, he's not going to be able to say, I had 6th-degree burns, because that would mean, I guess, he would burned up completely. He would have to say the worst one. So he would say, I had 3rd-degree burns on my body. So our little polynomial over here, when he wants to brag about how ugly is he only can say what his worst term is. So the degree of this whole polynomial, takes its size or its degree from the worst one. So this whole thing is called an 8th-degree polynomial. I hope my little snowman wounded warrior here helps you understand that. You don't add up all of them. I've seen kids on a test, they learn the degree of a single term, and then they sort of fall asleep, and then on the exam they add up all the exponents, which is not right. You have to look at each term separately, determine how bad it is, or what is its degree, and then the degree of the whole thing is the degree of the worst one of the terms. Now, I do want to say one other thing that students sometimes mess up with. If we had, let's see, I need to get my pencil back. If we had just a 3, what's the degree of just a plain old number? Actually, that's a 0 degree, because it doesn't have any powers on it. Like 3a is a first-degree term. 3a squared is a second-degree term. 3a cubed is a third-degree term, and so on. So when we talk about how many terms does a polynomial have, I should probably mention that too. Sometimes you'll be asked, how many terms in a polynomial? And if we had something like, if you say 2a plus 3b, that has 2 terms, and it's actually a binomial, as you remember. And if we have a squared plus 2a plus 6, this 6 counts as a term all by itself, even though he doesn't have any letters. This is a trinomial, and it has 1, 2, 3 terms. So now we've talked about counting the number of terms, and we've talked about the degree of a term and the degree of a polynomial when many terms are put together. Hope you get that vocabulary so that you and I can talk some more. Have fun. There should be some worksheets or some problems in some book that you can do on these terms and trinomials. Oh, and sometimes they ask you to say, evaluate a term to a squared b if a is 2 and b is 4. And that's just taking and going, substituting everywhere there's a letter. You put in the number that it's worth, and you do the arithmetic on it. So this would be the same as 2 times 4 times 4. 2 times 4 is 8, times 4 is 32. So sometimes you have to evaluate. I have an actual program that will ask you about evaluating. So maybe look for that video. Thanks. Bye.